right, Josh. Today I've got 5 hydraulic terms for you, and I was hoping you could give us some insight on them, why they're important to anyone working with fluid power components and systems.
Sure, fire away.
All right, first off, bulk modulus.
Bulk modulus describes the compressibility of matter, or more specifically, the incompressibility of matter. Everything is compressible, even steel, and bulk modulus is the figure that represents how hard it is to compress something. Bulk modulus is essentially the pressure it takes to reduce matter by a given amount. Bulk modulus is important to factor into highly accurate and utterly massive hydraulic systems. We must factor how much oil can compress when calculating motion. Compressibility will delay motion when the control valve is open, and it will cause delay in stopping when the control valve is closed. Although hydraulic oil compresses less than 0.5% per 1,000 psi being exerted, this can add up to large volumes with very large pressures. Systems with both high pressure and volume can see decompression shock when pressure is released, sometimes causing damage and other problems. For example, a forging press could have 20 gallons of oil or more being compressed just 2% of its volume over 5,000 psi. When the pressure is removed via directional valve shifting, for example, all of that compressed energy wants to be liberated all at once, causing sometimes horrific and damaging shock wave.
Yeah, for sure. Anyone who's been near a large press can attest to the seismic activity felt for hundreds of feet in all the directions around the plant.
That's right. Decompression shock can be limited via special valves designed to bleed fluid off slowly at first and then allow pressure to decay somewhat before full retraction begins.
Second term is beta ratio.
Well, beta ratio describes the efficiency of a hydraulic filter. A beta is the ratio of standardized dust particles measured before a filter compared to the number of particles measured after the filter. The micron rating must be expressed to be valid because every filter has a good beta ratio when you're filtering marbles. If a filter element is a B10 1000, that means that if 1,000 10 micron particles enter the filter, only 1 particle will be measured after the filter. Beta ratio can be converted to efficiency by subtracting 1 from the beta and then dividing by the beta. For example, 10,001 divided by 1,000 equals 99.9% efficiency. Filter efficiency is tested using a single pass test, meaning that B10, beta 10, 1000 filter will remove 99.9% of the 10 micron particles in just one pass through it.
That's pretty efficient. Let's move on to hysteresis.
Hysteresis in fluid power describes the difference in performance from when a usually electrohydraulic component remembers its actuated state compared to its relaxed state. So for example, when you fire a solenoid valve's coil and then remove current to that coil, the magnetic field still exists and tries to keep the valve slightly shifted. The difference between where the valve stays shifted and its intended position is its hysteresis.
So is less hysteresis better?
That's correct. Hysteresis is often expressed as a percentage and can range from 0.1% on high response proportional valves, which use integrated electronics and spool position feedback to maintain accuracy, up to 7% or more on inexpensive proportional cartridge valves.
Okay, number 4, through center, or as you Canadians would say, through center.
Okay, skip over this term if you're a mobile hydraulic specialist. But if you're an industrial specialist, you may want to pay close attention. A mobile valve, such as a monoblock valve, has 3 internal sections: the power pressure core, the tank core, and the through center core. These valves require detailed descriptions during decisions to clarify their exact configuration because words used to describe an industrial valve can be misleading for a mobile valve.
Okay.
A mobile valve has a through center core regardless of standard spool configurations. You can have all ports blocked, P, T, A, B, blocked in neutral, for example, yet still have a fixed pump flowing through the center of the valve where it joins to the tank core and is plumbed right back to tank.
Okay.
If a power beyond plug is installed, which separates the tank and through center cores internally in the valve, this very same valve can provide downstream flow to a tandem center industrial valve where fluid flows from P to T in neutral. Only the mobile valve will still have P, T, A, and all blocked.
Okay, but what about for mobile applications?
A mobile valve must have its power beyond adapter installed with the power beyond port plugged and then turned into a true center closed center valve where it will not flow at all in neutral. Often in mobile hydraulics, open center and closed center refer to the use of either fixed displacement pumps or variable displacement pumps.
Okay.
It is important to know the term open center can apply to a mobile valve with A and B ports still blocked, with a motor spool or even a proper all ports open spool, though through center simply allows power beyond capability.
Okay. And now down to the last term, centistoke.
Go ahead and search for the definition of centistoke. You'll get web pages of engineering technical jargon and ridiculously obscure definitions, such as this actual result from an online dictionary. A unit of kinematic viscosity that equals 1/100th of a stoke.
That's very helpful, I think.
Centistoke describes the kinematic viscosity of a fluid, or in simpler terms, how thick the oil is as it flows. See, I told you it was simple. A test rig for measuring kinematic viscosity is simply a graduated cup or accurate measuring lines with a calibrated hole in the bottom. The hole is 1 millimeter square. Sample fluid is added to the cup, and the time it takes for the given fluid to drain out of the hole is how many centistokes the liquid is.
Okay.
When you see a particular grade of oil, for example, an AW68, for example, the AW means anti-wear, and the 68 describes the oil's kinematic viscosity in centistokes at 40 degrees. An AW34 weight oil will take exactly half the time to flow through the same calibrated orifice into the bottom measuring cup as would an AW68 oil. An AW17 weight oil will take exactly half the time. You get the picture.
Absolutely. It actually reminds me of a video that I shot some time back. But I think that's all we have for today. So thanks for watching. And in the meantime, visit fluidpowerworld.com for more videos.